Okay, ma? So next concept which we are studying is expansion of liquidsma. Very, very important concept. At least in every 2-3 exams, you will get one question from this one. Okay, ma? Expansion of liquid. See, ma. So we are taking a glass beaker and we are filling water up to this position. Akka subaka. Inali first. Idedo sodi japkuntandre annattunte etla vinu first. Okay, ma? So therefore, this is what? This is actual level of water, no, ma? Actual level of water. So a bit intellectual concept, no? You have to use your brain, unfortunately, which you don't have that habit. But please use your brain, otherwise you cannot understand this one. Sima. So this is the actual level of water present inside this beaker. Then what I am doing is I am starting to heat this beaker. Okay, ma? So if I start heating this beaker, Sima, first of all, water doesn't expand. For example, if this liquid is water, first of all, water doesn't expand. First of all, glass will expand. Understood, no? Because if you take a specific heat of glass is less when compared to specific heat of water. What is meant by specific heat, we will study afterwards. First it will expand. Then if you continue heating, it will melt. Okay, ma? And if you tie by some thread and if you put some pressure on that one, then it is going to break. Understood, no? Okay. So specific heat of glass, it is always less than specific heat of water. It means glass temperature rises fastly when compared to temperature of water. You are supplying same heat energy. But whose temperature rises by very large value? Temperature of glass rises by very large value because its specific heat is lesser. Okay. So what is the first point we write? As we start heating, okay, ma? First of all, what happens? First, temperature of glass starts rising by large value. Okay, ma? Temperature of glass increases by a large value. Therefore, what happens? Which one expands first? Therefore, glass starts expansion. Okay, ma? Water doesn't expand immediately. First, glass will expand. Therefore, volume of glass beaker increases. Okay, ma? What happens to the volume of the glass beaker, ma? Volume of the glass beaker increases. So if volume increases, can you say what happens to the level of this water, ma? Level of water decreases. Okay, see, ma, here, listen. So this level of water, it falls up to here. Why level of water falls down? Level of water falls down because volume of the glass is increasing. No? So automatically water level will fall down. Okay. So water level falls down initially. Okay. Then if you continue heating, then what we are doing then? We continue heating. Okay, ma? If we continue heating, what happens? Now the expansion of glass will stop and expansion of water starts. Understood, no, ma? If we continue heating, expansion of glass stops. And what happens, ma? And expansion of water starts. Expansion of water will start. Understood, no, ma? And once expansion of water starts, what happens? Again, level of water starts rising, no? Are you able to understand, ma? So therefore, what we write? So, level of water starts rising. Understood, no? So listen. So first what happens? This was the level of water now, no, ma? This is the level of water when glass has expanded. This is the level. Okay. Namaskaram akka meeku. Vinali. Okay, ma? So this is the level of water when glass has expanded. Clear, no, ma? Now when we continue heating, what happens to the water? Now water starts expansion, no, ma? So therefore water, first of all, it reaches to the original level. Okay, ma? Actually, this was the original level, no? It has fallen down because glass has expanded. Now this water, first of all, it reaches to the original level, then it goes beyond the original level. Okay, ma? So therefore, this will be the final level of water. Final level of water. Are you able to understand what is happening? So first glass is expanding, so water level is falling down. Okay. Now when I continue heating, what happens? So expansion of glass will stop and water level is continuing to rise. So first it reaches to original level, then it goes beyond the original level. Are you able to understand? So these many processes will happen when we start heating water in any beaker. Okay, now see. Now each level we have a different name, so that is very important. See, so this one, this fall in level of water is because of what? Expansion of glass. So this is because of expansion of glass. Understood, Nama? Expansion of glass. Okay. Now see. So this one have you written, ma? So first make a note of the diagram up to here, then we will continue. See, ma. So this we have studied already. So this fall in level of water is because of what? Because of expansion of the glass. Glass is expanding. It means that much amount of volume of glass has increased. That's what I can understand. No? So what is the volume of water reduced? Same will be the volume of expansion of glass also. Okay. Now see. So we have to study some more two levels. Ma. Now see. Now can you say what is this level? What is this level? This is called apparent expansion. Apparent expansion. What is meant by apparent expansion? Ma? Apparent expansion means the expansion which you see with your naked eyes. Okay? You are keeping water on a heater, on a stove, and you are leaving the place. Then after some time if you come, then this is the rise of water which you see, no? So the expansion which you are seeing with your naked eyes, that is called as apparent expansion. Ante meeku anipistuna expansion adi. But that is not the actual expansion of water. What is the actual expansion of water? Okay, ma? Where shall I write? Here I will write, ma. This is apparent expansion. And if you take this total, this is called as real expansion. Are you able to understand? Why it is called real expansion? Because water level started from here, no? Rise of water level started from here. First of all, it has gone to original level, then it has gone beyond the original level. So therefore, from here to here, this is total expansion of water. Understood, no? So that is why this expansion is called as real expansion. And what is this expansion? This expansion is only the expansion which you see. Meeku kanipiste expansion ante. Because initially you know original level. This is the original level, no? And after heating, you will see only this level. But reduction of water, again, water going to highest positions, all this you don't understand. Are you able to understand, Amma? So therefore, this expansion is called real expansion, and this is called apparent expansion. Or you write in full form. AE means what? Apparent expansion. The expansion which you see with your naked eyes. And fall in level of water was also there, no? And that was because of glass expansion. Understood, no? Therefore, can you say, how can you write relation between all of them? How can you write relation between real expansion, glass expansion, and apparent expansion? Real expansion is equals to apparent expansion plus glass expansion. That's it. Okay, ma? So therefore, we write real expansion is equals to apparent expansion plus glass expansion. This is what we write. Okay. I can write like this number. This is total real expansion, sum of glass expansion plus the apparent expansion, expansion which you see with your naked eyes. Okay. And delta V already we have studied, Noma. For example, what is gamma value? Coefficient of volumetric expansion. Delta V divided by V delta T. This is the equation, no? So therefore, what is delta V? Delta V is equals to V gamma delta T. This is the relation, Noma. Already we have studied, no? Substitute in the above equation. So how can I write real expansion? Listen. Real expansion means delta V real. Change in expansion, real expansion of liquid is equals to expansion of apparent, that is apparent expansion plus expansion of the glass expansion. I can write like this, no? Okay. And same relation I want to write in terms of the actual equation. How can I write? V means original volume. Gamma means, here I will write gamma real. Okay, for 3 different conditions, I can write 3 different gamma values. If I want to measure only real expansion, I will calculate gamma real. Okay, coefficient of volumetric expansion for real expansion. Understood, no? Similarly, if I want to calculate only apparent expansion, then instead of gamma, I will write gamma apparent. Okay, the coefficient of volumetric expansion only for apparent expansion. Okay, apparent expansion means the expansion which you see finally. Understood, no? Similarly, if I want expansion of only glass, then I will write gamma glass. Coefficient of volumetric expansion of glass. Okay, so therefore, how can I write delta V, V gamma delta T, no? So V gamma real delta T. This is how I can write. Apparent expansion, how can I write? V gamma apparent delta T plus delta V glass, V gamma glass delta T. This is how I can write. Understood, no? So V, volume is same, no, for all of them. Glass volume, water volume, everything is same, initial volume. So you can cancel all of them. Change in temperature is also same, no? You can cancel all of them. So what is the final relation I got? So gamma real is equals to gamma apparent plus gamma glass. This is what I will write. Understood, no? So coefficient of volumetric expansion of real expansion is equals to coefficient of apparent expansion plus coefficient of glass expansion. Okay, so questions can be given on this one, and very frequently you will get questions on this topic. Understood now up to here? Okay, now see. So we will try to understand this one by taking some more detail. Sima. So gamma of glass can be written as 3 times of alpha of glass. Can I write like this? Because yesterday we studied this relation, no? Relation between alpha is to beta is to gamma is so much, 1 is to 2 is to 3. So therefore gamma of glass is 3 times of alpha of glass. So therefore same relation, how can I write? Gamma real is equals to gamma apparent plus gamma, or I can write 3 alpha of glass. I can write like this. Now we will study about apparent expansion. Apparent expansion means what? The final expansion which you see. Expansion which you see with your naked eyes. That is called apparent expansion. Okay, ma? Let us see. So, Sima, listen carefully. So, gamma apparent is equals to, I can write gamma real minus 3 times of alpha of glass. So, this is a very, very, very important relation. Okay, ma? Why it is so important? Written up to here? Right. Sima. So now we will study 3 cases by using this relation. So what is the relation we have written? Gamma apparent is equals to gamma real minus 3 times of alpha of glass. Or you can write gamma of glass also, no problem. Okay, ma? Now see. Case number 1. Case number 1 is, okay, gamma real is greater than 3 alpha glass. Then can you say what happens, ma? Coefficient of real expansion of liquid is greater than, that is 3 times the coefficient of linear expansion of glass. Then what happens? So if this value is greater than this value, gamma apparent will be positive, no ma? Gamma apparent will be positive because first value is greater than second value. So gamma apparent positive means what? Water level actually increases. Water level increases. So therefore what gamma apparent is positive means what? Water level increases. Okay. It means here you are seeing this apparent expansion. This is rise in level of water only, no? That water level you can observe to be rising. Okay. Case number 2. Case number 2 is when gamma real is equal to 3 times of alpha of glass. Then what will happen? 0 means what? So gamma apparent will become 0, no? Gamma apparent becomes 0 means what? So whatever may be the heat energy you supply, you can never see water level has increased or you can never see water level has decreased. Because both are expanding. Okay, ma? Glass is also expanding by same value, water is also expanding by same value. So you don't find any change in level of water. Water level doesn't reduce, water level doesn't increase also. So therefore what we write, change in level of liquid is 0. There is no change in level of the liquid. Case number 2. Now you can write case number 3, no ma? What is case number 3? Case number 3 is gamma real is less than 3 times of alpha of glass. Then what happens? Water level falls down. So even after heating for large time, you will see water level has finally reduced instead of increasing. Okay? Therefore what we say, water level or liquid level, anything you can say, water level falls down. This is what you observe. Why water level falls down, ma? Because apparent expansion has become negative. Okay? So these are the 3 conditions which you should remember, ma. So whether finally glass water level has increased or decreased, it depends on the comparative values of these 2. What is the expansion of liquid and what is the expansion of glass? Depending on this, we can find out whether finally water level has increased or remained constant or water level has decreased. So everything depends on this equation. Understood, Nama? That's it. Okay, Sima. So ఊరికైనా ఫేమస్ క్వశ్చన్ ఏంటది ఇది, ఏదో చిన్న లాజిక్ ఉంటేనే ఫేమస్ క్వశ్చన్ అయి ఉంటుంది. చూడండి. సో 1 liter flask, consider this is a liter flask. Volume of the glass flask is 1 liter. Shape of the glass is horrible. So this is the glass flask. Clear? Capacity is 1 liter. So in this flask, some mercury is present. How much amount of mercury is present, we don't know. Understood, Noma? This is the amount of mercury is present, and that volume of mercury only you are supposed to find out. So volume of mercury, how much is it, that you are supposed to find out. And what is the data he is giving at a different temperatures, volume of air inside the flask remains the same. So this is the volume of air, Nama. This empty space which you are seeing, this is volume of air. That's all, no? So volume of air, it is a constant. It means when you raise the temperature of this glass flask or when you cool this glass flask, whatever may be the temperature, volume of air should always remain same. That is the given question. Now in which condition volume of air can remain constant? That is what you have to think. But alpha values are given, no? It means definitely they will expand. When expansion of glass and expansion of mercury, when they are equal. Okay, ma? What is the amount of expansion in glass flask? If same is the expansion in the case of mercury also, then the volume of air always remains constant. That is the case, no? Clear, no, ma? See, if mercury expands by greater value, then what happens to the volume of air? Volume of air reduces. That's it, no? Similarly, when glass is expanding more when compared to mercury, then what happens to volume? Volume of air increases. But volume of air remaining constant means expansion of glass and expansion of mercury, both of them, they are equal. That is the point based on which this question is framed. Okay, ma? So therefore what we say, for volume of empty space, to remain constant, what we have to write, ma? We have to write change in volume of glass is equal to change in volume of mercury. Then in this condition, air volume always remains constant. That's it. And delta V is how much? Delta V is V gamma delta T, no, ma? So V of glass multiplied by gamma of glass multiplied by change in temperature okay, ma? See. Okay, sigma. So this is equals to the change in volume in the case of mercury. So how can I write volume of mercury multiplied by gamma of mercury multiplied by change in temperature? That's all, no? So change in temperature remains same, no? If you heat both of them, they get heated up. Temperature remains same. So you can cancel them. And what I want volume of mercury only, no? Volume of mercury is equal to volume of glass multiplied by gamma of glass divided by gamma of mercury. That's all, no? So volume of glass is 1 liter, no? And 1 liter is equal to how much? 1 liter is equal to 10 power minus 3 meter cube. Okay, ba? Because liter is not SI unit of measuring volume. Meter cube is the SI unit. 1 meter cube contains 1000 liters of any liquid. Okay. So therefore 1 liter is equal to 10 power minus 3 meter cube. So substitute here. So 10 power minus 3 meter cube is the volume of glass. And what is the gamma of glass? Alpha of glass is given, number. Multiply it by 3. It converts into gamma. So therefore 3 times of alpha of glass divided by gamma of mercury. What is the gamma of mercury? 1.8 into 10 power minus 4. So it is 10 power minus 3 multiplied by 3 multiplied by alpha of glass is how much? 9 into 10 power minus 6 divided by 1.8 into 10 power minus 4. Okay, so do this calculation. That is the volume of mercury. Understood, Nama? That's it. So the answer which you should get is 150 into 10 power minus 6 meter cube. So 150 into 10 power minus 6 meter cube. That is the volume of mercury. So if this much of volume is present, then the volume of air always remains constant. That's it. Okay.